Hello everyone, this is Sudesh. I lead the CSA San Francisco chapter along with Satish and Mega and others. All right, so our next speaker is Patrick, and Patrick will talk about the vulnerability management and the new ways of measuring the exploit prediction using EPSS. And EPSS represents a data-driven initiative designed to estimate the likelihood of a software vulnerability being exploited in the real world scenario. So with that, I will hand it over to Patrick.
Sweet. Thanks for having me today. Yeah, well, I'll hop in and give you a little bit of background. And as we're talking about this, I think I can go through also some things quick. Let me know, I think some of it's foundational knowledge, if that's helpful on CVEs and NVD. And one of the shifts in the market I like to preface with. I'll try and get through that pretty quickly so we can hop into the crux of EPSS. And how much time do we have, by the way?
We have 30 minutes, so you're good.
Okay, cool. Great. Let me share my screen. Can you see my screen now?
Yep.
Looks like. All right, great. So a little bit of background on me. I work at a company, Nucleus Security, do a lot of security research. A lot of people know me for the data visualizations on vuln data related to NVD, EPSS, CVSS, CSA, Mandiant, threat actors, as well. Previous to Nucleus, I helped build Census, Duo Security, and Blumira. And Census was spun out of the University of Michigan. And giving some context here as far as like why EPSS, and what EPSS is. Before I hop into these details, like EPSS is an open standard. There's a special interest group on first.org. Anyone can participate. So it's you can think of it as an open standard. It's being incorporated into a lot of different products, which I'll talk about. But the reason why it's important, some history of why it's important is, first off, for the last couple of decades, vulnerability management was a pretty low priority. And, most organizations relied on CVSS scoring to determine what to fix. And most of the, vulnerability patching was based on your network scanning. So you're like Tenable, your Qualys, Rapid7, other products there. And reality is like it worked pretty well. And I think a lot of that has to do with the fact that there wasn't pervasive amounts of mass exploitation or vulnerabilities, which I'll talk about really fast. And the first thing is just what I'm going to show here is the rise of vulnerability. So this is a data visualization I created to kind of like set the stage in regards to the NVD. What you're going to see is that the vulnerabilities grow year over year consistently over the last 2 decades, to a point where for most organizations, this has gone neglected and become unmanageable. So, I mean, you can kind of just see, generally speaking, depending on the organization, they're not resourced to keep up necessarily with the scale at which vulnerabilities are being published, disclosed, and discovered. And in addition to that, I think an important note in why EPSS and other threat intelligence becomes really important is the last decade before 2022, really the attackers were predominantly using phishing attacks. And this was pulled from Mandiant's M-Trends report in 2020, which is more of the same, more phishing, everything is phishing. There hasn't been any change. Like literally that's their words. Reality is in 2023, the new report, number one attack vector is now exploitation. So organizations very rapidly are being caught in a situation where it wasn't much of a problem. But really when 2020 hit, and we started to see COVID pandemic, we started to see, more mass scanning technologies, even being involved in Census myself. Access to environments and exploits became more pervasive. And another reason why was MFA made credential compromise much, much harder for attackers. So just to shift generally in how they're going about attacks at mass scale. And so, historically, you have the common vulnerability scoring system, CVSS. And if I map this out accordingly, I like to tell stories through pictures, but it's the most widely adopted scoring system. The challenge is 56% of vulnerabilities are 7 or higher critical, which makes it really difficult. So you can see the vulnerability growth in addition to most vulnerabilities being rated really, really high. And so the scoring system essentially has become very difficult with using the base score, which is what most products support. There are other capabilities, and I don't want to discount CVSS. I have distribution here. As you can kind of see, the deeper colors show higher scores, 7 or above. So 56% are 7 or above. There is a new version coming out, so there's some promise here. And we could talk about that all day. But unfortunately, like, this system hasn't been working. It does not have threat intelligence incorporated in the system by default, even with 4. And so there's need for ways to understand what's going to be exploited now, which is typically your certain forms of threat intelligence, and then what's going to be exploited in the future, which is what the exploit prediction scoring system really focuses around. So with this, we have the rise of vulnerability threat intelligence. If you look back, like, vulnerability threat intelligence was not accessible until recently. I'll talk about a few different projects that are open standards. Most people, if they had vulnerability threat intelligence, got it through commercial feeds. So that would be like a Mandiant, a recorded future, Intel 471. However, that data has historically been pretty minimal. So it's going to tell you some evidence of things like exploitation or ransomware for certain CVEs, but it's not going to cover everything. And it's incredibly valuable. I don't want to discount it. So there's many different sources. So like known exploitation, CSA, the exploit prediction scoring system is predicting the future, right? The next 30 days, whether something has a high probability of being exploited. You have OSINT sources like Metasploit, GitHub, which actually are incorporated into EPSS in some ways, and then commercial threat intelligence. And we always want to encourage people. It's like, the more sources you use, making sure you understand how they work is valuable. It's important even with EPSS that you still use things like CSA with known exploitation, because known exploitation is different than predicting the future of what will be exploited. And you likely want to patch things that have been exploited historically, or might have threat actors or ransomware associated with them, which is where commercial threat intelligence works. So the exploit prediction scoring system, you can see here, it's quickly becoming the second most widely adopted scoring system in the vulnerability world. And it specifically addresses, just like CVSS, CVE-based vulnerabilities. So what's pretty exciting is, like, it's now becoming accessible to the masses through common tools that people use, which excites me because that's like one of the major steps. So if I looked at this 3 months ago, we probably would see about a third of these vendors. So it's getting really broad adoption really, really fast. What EPSS is, so very simple put, here's the data. EPSS, when you call the API, you can submit a CVE, and it's going to give you back 2 components. The exploit prediction score, the scoring system itself, and that is between 0 and 1. And it ranks based on probability of exploitation. And then the second piece of it is what percentile that scoring threshold is in. So for instance, a 0.00363 score would be in the 68th percentile of EPSS. And that's it. Like, that's really simply put, like, you can query it, you can use it in your tools, and you can prioritize based on it. So for instance, if I look at this list, a 97% probability of exploitation in the next 30 days, probably want to do something about that. Whether it's patching, mitigating control, or doing something, especially if, for instance, it's externally exposed. So if we hop in and take a look at this, like, taking a step back, the circle is all vulnerabilities, the gray circle in total, right? And this is data from December 1st. We have a blue circle, which is CVSS 9 or above, which is considered to be critical with the common vulnerability scoring system. And then we have actual vulnerabilities that are exploited in the wild, right? And that's what that red circle is. And there's really, 4 different components. If you think here, you have true negatives, you have, false positives, right? So true negatives would be vulnerabilities that are not actively being exploited and are not rated 9 or higher. You have false positives, which would be CVS 9 or higher, that are not being exploited in the wild. You have true positives, which are covered by CBSS in this instance. So we have some coverage of things being exploited in the wild. And then you have false negatives, which means there's a bunch of things exploited in the wild that you don't have coverage on when using the CBSS scoring system with threshold of 9 or above. We can take a step further. So like blue, essentially we can look at, hey, what's the actual work effort involved? So the blue circle is going to involve work effort when we have 9 or above. And this is going to help as I break this down to show comparisons as far as like things like effort and efficiency in a moment. And then we have coverage, which is TP, which is right here, right? And we're looking at specifically how much coverage of the exploitation does CVSS 9 or above have. So it's actually a small portion that you see there. And then efficiency is essentially what percentage of the prioritized vulnerabilities were actually exploited over the next 30-day period as well. So if you take all this, essentially, we can look at this and do comparisons to look at the CVSS scoring system, which is what most people historically have used. And currently that's on version 3. And we can see with a 9.1 threshold, we have, from a coverage perspective, a little bit, but not a ton from future exploitation activity. If we look at the different versions of EPSS first came out in 2020, and then there's been a new version in 2022 and 2023. We can see progression where, initially with the same exact work effort as using CVSS 9.1, we're actually able to get significantly more coverage of things that were exploited over the next 30 days. And as the protocol has worked on improving the model, essentially, you can see continuation of getting better and better coverage of things that are potentially going to get exploited or were actually exploited in this study over the next 30 days. All right, I went through a lot there. So I'm going to hop into some more, but any questions or observations before I move on?
So Patrick, this is great. One question here. So comparing CVSS 9.1 plus threshold versus
Yep.
comparing with EPSS V1 threshold 0.062 plus, how does EPSS get visibility into visibility into the prediction? Does it needs to
Yeah.
know the vulnerabilities or yeah?
Yeah. So there's a combination of elements that, it's a machine learning model,
Mm-hmm.
and it has inputs built into it that are used there's a few different inputs. One of them is, okay, we're collecting data, and some inputs might be Metasploit data,
Mm-hmm.
GitHub security advisory data, Twitter data. And I think that's an interesting one because, like, right now in version 4. It'll be interesting to see what we do with that, as Twitter data has dropped off a lot, right?
Mm-hmm.
There's also contributors of threat intelligence in the protocol. And then we're also underlying using CVSS metrics, not the score itself. So the scoring is built on different metrics.
Mm-hmm.
So those are also used. There's also things like vendor tagging. And so there's a few, I think it's a few, I know it's hundreds, I think it might be thousands of attributes that essentially allow the machine learning to identify the probability of something being exploited based on those underlying attributes. Age is actually another one, for instance, like
Mm-hmm.
older vulnerabilities have a higher probability of exploitation, right? Um, is an example of that as well. But that all factors in, like, and then what happens is then there's validation data. So exploit data from Fortinet and Alien Vault and Gray Noise and a few other threat sources. So that's how we're comparing CVSS version 3 and EPSS version to show how much coverage there actually is.
Okay, got it. Got it.
This is CVSS version 7. So to show a coverage example, right? So if you use 7 or above, you have to patch 58% of all CVEs. And then on the bottom right, you can see the efficiency is with EPSS, you can set a threshold of 8.8% probability, or 0.088, and you will be able to cover the same amount of exploitation with just 7.3% of the work effort of all the vulnerabilities. So it's a much, much more efficient way to get to similar results from a prioritization perspective. To break down some examples and on my side in regards to the giving examples as far as how this data flows. On the left-hand side, this was all CVEs that were rated on CVSS version 3.1 as a 10, which is the highest score. And we can see here on the right-hand side, the EPSS probability of exploitation, just because something's a 10 and critical on the CVSS scoring system does not mean that it ever is going to be exploited, right? So out of those 420 vulnerabilities, we have 25 that are 90% probability in the next 30 days. We have 13 additional ones that are 5% higher, and then 42 additional that are 1% or higher. So like this really helps you prioritize the things that are most likely to be exploited, which is great. And I think there's different approaches. Like many organizations are still looking at known exploitation with the KEV, and then going behind that with EPSS. Or in some cases, we see people using EPSS, and a lot of times that's a leading indicator if a vulnerability will then end up on the known exploited vulnerabilities catalog. So I think it's really interesting to see the usefulness and the effectiveness as far as different ways organizations are adopting and using the exploit prediction scoring system. To break out a little bit further, this is, and then I have one more, and then we can chat about EPSS, any questions, observations. But this is the full National Vulnerability Database, broken out by CVSS score. And you can see here the breakouts. This includes all versions of CVSS, so not everything's scored with the newest version either. But in order, for instance, if I want to do 9 or higher, it would require me to, patch 30,000 vulnerabilities that are on the NVD. Now, that's not considering your asset context or other factors within your environment. How many of these vulnerabilities might you have? But in order to get to the same result from a coverage perspective, you literally could do that by patching just 4,600 vulnerabilities. So, a lot customers can go as deep as they want, but it's a more effective system in relation to focusing on, things that are much, much more closer to a risk-oriented approach than just the CVSS base scoring system. One last one I'm going to show is just, the colorization here in the color bars. And I know I need to work on my my colors because if you're colorblind, I'm sorry. I'm learning. People are teaching me on my data visualizations, but essentially, like work effort is broken down here with CVSS version 3 on the left, and then EPSS on the right. So this kind of shows you on the left here. We can see CSS version 7, you would have to do 56% of all vulnerabilities in NVD. Whereas with EPSS, in order to get the same exploitation coverage, from a work effort perspective, we're right around, I don't know, I think it's like 15% of vulnerabilities. So just a much, much more effective way to focus on the aspect of threat in an organization when you're running a vulnerability management program. The other thing I do want to emphasize is a lot of even intelligence sources and firms, their analyst teams are using EPSS to look at high probabilities because of the way it's incorporating data and picking out these vulns. What we find is that then you can use that to research the vulnerability from an analyst perspective on the commercial intelligence side and likely get supporting data beyond EPSS, which is a huge win for commercial threat intelligence and huge value for customers as well. So a lot of different ways, like people are using EPSS, but we see people incorporating both on prioritizing the vulnerability side and then also on the research side. Organizations, blog post by Mandiant, for instance, their team actively uses it in that way with the commercial and threat intelligence side as well. So I think that's about it.
So thanks again, and I look forward to it, and have a great evening.